Hello YouTube. Today I'm going to be working on this. This is a laptop sent in by a customer of mine who has tried fixing it himself and eventually gave up and decided to send it here. I love jobs like this. So we have an MSI Prestige 14 AI Studio. And I think it's been sent for no power, and it's been sent in pieces. The battery is held in by one screw. The heatsink has no screws in the main cooling part of it, but it has a couple of screws in the fans. There is stuff trapped under the board. The board is slightly flexed. Probably not the best way to ship a laptop, but whatever. Now I've been told one of these charging ports gets 20 volts and the other one gets 28, I think, if I'm remembering that correctly, which again is weird and not something you'd expect. But we're going to take a look at the USB-C, we're going to take a look at its behavior, and we're going to see if we can get this laptop working again. This laptop's not very old. It was built in late 2024, according to the base plate. And it would be a real shame if we couldn't fix it. But let's see what's going on with it. Before we can really dig into this, I'm going to take out the battery with the one screw there. I'm going to take out the fans, take the cooling system off, and just pull the board out of the chassis because I don't want to plug it in whilst there's stuff under the board and the heatsink's not properly attached and stuff like that. So let's do that. I guess at least it's easy to take apart. 3 screws later and it is out. Okay, let's get the board back in camera and plug in my USB-C cable to the bench power supply. We've got it set to 20 volts. We've got this little LCD here that's drawing a little bit of power by itself. So we've got 33 milliamps to start with. And when we plug in that port, we get 54, and it's reading at 19 volts on that little LCD there. I'm not sure if you'll be able to see that. So that looks like it's boosting USB-C. And what about the other port? That one is also registering 19 volts. Okay, and these ports are reversible, so let's turn them over, make sure they're all behaving the same. 19 volts there, and 19 volts there as well. Okay, so USB-C seems to be negotiating, so I guess that's good. I'm not sure why he thought it was getting 28 volts, but I'm not. Now, let's plug in the battery and see if it charges. Okay, it's drawing 1.1 amps. Let's just get you under the microscope. We have this, this is the battery connector here. Just to the left of it, we have this big resistor, which is the current shunt resistor for the battery charging. So this resistor will help the charge IC determine how much current is being pulled from the battery, or how much current is going to the battery, I believe. But we'll measure the voltage there, and it is 17.5 volts, which looks like a healthy battery voltage. And if we unplug the USB-C, that drops to 17.0. So when USB-C is in, it is definitely charging the battery. Okay, the mystery continues. So we have battery charging. We should double check the 19 volt rail. If we have battery charging, we probably have 19 volts to all the important regulators. For example, the CPU regulator and all the power supplies on the board will have a 19 volt feed going in. We probably have that if we have battery charging, but there's no harm in checking. So let's find some GPU MOSFETs. You can see a big capacitor there and a big thick trace feeding these two driver MOSFETs. So yeah, and that's 17.5, which is battery voltage. Again, that's normal. Because we have charging, we know that the EC chip's working, because the battery wouldn't charge unless it was recognized first by the EC chip, which automatically means we know that the EC chip has power, we know that it's reading the battery correctly, and so we can sort of move past that part of the diagnosis and on to the next, which is, does anything get warm? Is it trying to turn on? Do I need to find a power button to try and get this board to power up? And we have two buttons here, one there, and one there. And I don't know what they do. One of them probably clears the CMOS, and the other one maybe powers the machine up, so let's press that one. And looking at the current, it did something. It turned everything off for a second, and then back on. Went up to 1 amp, and it's dropped back down to 600 milliamps, which is where it was before. So I think that could be clear CMOS on the right-hand side. Let's try this one on the left. This one doesn't do anything, which is interesting. Nothing at all. Okay. Does it have anything written around it that will give me a clue as to what that button does? Sometimes, if you're lucky, the silk screen around it will say something like power button or test point power button. I think that one just says SW1 and there's PQ8 maybe above it, which would probably refer to that chip there. So it doesn't necessarily say that it is a power button. And it doesn't respond. I imagine we've got 3 volts coming into it. Yeah, so there's 3 volts there. 3 volts on that pin. And then I guess no volts anywhere else. Which is interesting. But we don't have a schematic and we don't know what this switch does. It's probably a debug power button, but we don't know for sure. Anyway, the machine doesn't seem to respond when we press it. Let's unplug the battery and just give it one last press of that power button. 60 milliamps, 57, and you press it and nothing happens. You press the one on the right hand side, and nothing really happens. Okay. So, what else can we look for? There is a RTC battery here. Does that have the correct voltage, or is it flat? Oh, I'm not measuring it. There we go. Okay, so that's not flat, which is, it's not a bad thing. We still got an SSD in this board? Yeah, I should probably take that SSD out before I do any soldering. Let's just take a look around the board. 32 gig of DDR5. At least if we can't fix the machine, they can sell that RAM. Okay, so we've got a couple little power supplies up around this GPU, which looks to be a 3050 or a 4050 or something like that. 6 gig card. And some CPU phases powered by a monolithic power chip, which will probably have some firmware on it, so let's hope our failure is not with that. And CPU, I'm not sure what generation this is, or whether it might be a Core Ultra. Yeah, it's got to be a Core Ultra. Let's just take the thermal paste off that and see how many dies there are. Is it just one or is it loads? Yeah, there we go. Thought so. This will be a Core Ultra of some kind. You can see you've got, what, 4? 1, 2, 3, 4 sections of silicon here that make up the CPU. I'm guessing one is the PCH, one might be graphics. The other two, I don't know. Power cores and efficiency cores, maybe. I've not spent too much time researching this new architecture, so. But it's got some stuff going on. What have we got down here? Charge circuit, USB-C controller, BIOS chip, and some connectors. Oh, and Wi-Fi down there as well, and a couple of power supplies down there. But nothing suspicious. Let's, there's a sticker on the back of the board. Let's just quickly pull that off and go back over the back of the board. Again, a couple of small components, but it's not particularly densely populated. I wonder what that is. That looks an awful lot like it could be a charge IC. Yeah, it is. That's a BQ25770. You know, I'm glad I zoomed in there, because just to the left side of that resistor, Does that look a little bit brown to you? Let's just, whilst we're here, we can just check out resistor. It says 1RO on top. That means it's going to be 1 ohm. Well, if it's working. And we're getting 1.6. Which is fine. The 0.6 is just the resistance in the cables of my probes. So that's okay. Anyway, moving on. Nothing looks suspicious. So next, we should check all of our rails for shorts. We have good. That's okay as well. Over here, ooh, think we have a short. So the GPU's low resistance, which is normal. I wasn't really paying attention. What was this? I guess this is VRAM. And that's 40 ohms, which is good. Those two look good. Now, just because I found a short down here doesn't mean I'm going to stop measuring the output of all the coils. Because we could have shorts up here as well, which would point me towards possibly a larger failure. If there's one short circuit, yeah, this might be fixable. If there's 3 or 4, then this probably has quite a lot of damage. So yeah, we keep testing. Even if we find one problem, we keep testing, we keep checking for other problems to get a bigger picture of what's going on here. So we've got a bunch of coils up by the CPU. I'm not sure what resistance they're meant to be or what does what. As I say, I'm not very familiar at least with the Core Ultra processors, so I don't know what's gonna measure good or bad here, but we're gonna measure anyway. 3 ohms is probably okay. All of these are measuring okay so far. Okay, so it looks like the only short circuit I can immediately find is down here. And let's try and figure out what that does. Let's remove the CMOS battery and recheck just in case there's any power leaking on, but that's unlikely. Yeah, so that's still short. Let's remove the SSD because I said I was going to do that earlier. There we go. And let's bring you in to this area. So we have 2 configurations that seem to be mirrored. So we have a coil here, a coil here, a MOSFET here, a MOSFET here, MOSFET here, and a MOSFET here. So we have 2 power supplies that are pretty much exactly the same. They probably have a different voltage, but this one's short. Now I think one of these is going to be a 5-volt supply and one of them is going to be a 3-volt supply. And before we inject voltage, I want to see if I can figure out which of these is 5 volts and which of them is 3 volts without the schematic. To be fair, it could be 1.8 as well, but I think 5 volts and 3 volts is the likely situation. So these circuits will be powered by, I guess, something on the back of the board. Yeah, there we go. There's our little regulator. And this regulator here will drive both of those power supplies. And I think it's going to be a 3.3 and 5 volt regulator. So let's go back to our trouble area. Now, I don't know if I plug in power, if with this power supply dead, we'll get power on this one. But there's no harm in trying, so let's plug in power again, switch back to voltage, and see if we get anything here. Nope, nothing. Okay, what about here? No, of course we're not going to get anything there. That's our short circuit. Next, I want to see if I can find something that I know is fed by 5 volts. And the only thing I can think of right now is my USB power. So over here, we have power to USB, which will be generated at some point by a USB power switch and by 5 volts before that. So if I can check the resistance to ground, that's not shorted, which makes me think this might be 3 volts and this might be 5. So we might have a short on the 3 volt rail. But I don't know for sure. I'm just trying to figure out what our maximum safe voltage to inject here is. The next thing we're going to do is inject some power to the short circuit and see if anything gets hot. Keep our fingers crossed that the CPU is okay. Let's zoom you in a little bit. So what I've done here is I have still got the ground connected from this USB-C lead to the bench power supply. So I can plug that in there and use that as my ground. And I have plugged my multimeter probe into the positive side of my bench power supply, which means I can use this to safely inject power into this coil, and the thermal camera is ready to hopefully pick up some hotspots. So I've dropped the power supply down to 3 volts 3 amps, which should be relatively safe. Maybe because I'm not so familiar, maybe let's just drop this down to 1.8 instead. I think this is the 3 volt rail, but 1.8 is probably more sensible. And let's inject, drawing the full 3 amps. But I'm not seeing anything get hot. Can't tell if we've got a reflection. I think that's just a reflection. Okay. Oh! Dude, did I miss that? Yeah, we've got a short down by the Wi-Fi card. Possibly 2 shorts. No, just the one. That's a reflection. Okay. Cool. Okay, we finally found it. Let's see. I really hope it's not the Wi-Fi card itself, because I don't want to replace one of these. Let's just drop some alcohol on it. Man, I'm hoping it's that cap. Let's put some power in again. You can see the alcohol move just when I start to inject power. See how that reflection changes. I think it might be that cap. Let's increase our current all the way up to 6 amps. And see if that really starts to go. Yeah, there we go. Awesome. Okay, hopefully this is good news. Hopefully this is all we need to get the board working again. Let's just remove that capacitor. I don't think we need to replace it. You know what, I don't even think I need hot air. I don't want to melt. Oh no, that's not. Is there a sticker there? I don't want to get too much heat in this area. Let's just see if we can get my soldering iron in. Just zoom you guys in a little bit. Okay, I have that capacitor removed, so let's remeasure for shorts. That's probably the best practice. Make sure my eyes aren't playing tricks on me. Make sure that there aren't any more shorts on that rail. So let's check. And the resistance has gone to 350 ohms, 0.3k, which is about normal for a 3 volt rail. Well, what I think is a 3 volt rail. So let's set my bench power supply back up and we can check to see what it does. Can't be this simple. Another board repair guy had a look at this and couldn't fix it. So I don't know how he missed the short circuit. If you're watching this, check for shorts next time. Oh, it's just turning straight on. Okay. Awesome. I think it works. Let's check what voltage that coil was meant to get. And it is 3.3 volts, so my guess was correct. 5 volts on the one to the right, 3.3 on the one to the left. Perfect. So I'm gonna put some thermal paste on, put this back in the chassis, try and figure out where all the screws go, and see if we get anything on the display. We can have a screw for each fan, which will hold the board down. And we definitely need some screws for the heatsink, because otherwise we won't be able to test. But otherwise, I think I'm going to implement a new rule. If you send me a device in pieces, then you can put it back together yourself. I'll do enough to test it, but I don't know where you got these screws from. I don't know what screw goes where. I can probably figure it out. But I'd much rather receive devices fully assembled, so if you send it to me in pieces, I'll send it back in pieces. Give you a taste of your own medicine. That'll do for me. Plug the battery in. Loosely fit a base cover. And we can see if it boots. It's drawing 2 amps, which looks good. I can't tell if that's just charging or trying to turn on. I think it's probably trying to turn on. Yeah, because I had a charge current of 600 milliamps earlier. So let's zoom you back out. And wait until it displays something. Okay, backlight came on. There we go. MSI logo's come up. And it powered back off. Ah, there we go. What's it doing? 3rd time's the charm? Ah, asking for BitLocker recovery. I don't know why it's doing that, but it turns on. And it didn't before. So I think we're good. I think we're okay here. I'm going to test this off camera, make sure everything's working properly, and send it back to the customer. So, with that, I'm going to say thanks for watching. A special shout out to the customer that sent me an easy repair. Thank you for that. And I'll see you next time. Goodbye.